Thank you. Good afternoon again. I don't know how many of you were in my previous session, but again, I'll be introducing myself. So my name is Edson Yanaga. I'm a director of developer experience at Red Hat. My Twitter handle is at Yanaga. And I'm also a Java champion and a Microsoft MVP. So I'll just pass these slides very quickly because I guess that many of you have seen this already. But I'd like to say that now every company is a software company because software is changing the world. And in this world that is changing every day, developers are the most important people in the world because we can create this revolution using code. These are some of great examples of this new digital economy. Because the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies have in common something very simple, which is software. So software changes the world, and software creates this new digital economy. And when I'm talking about economy, one of the concepts that I had in my entire life was that economy was related to money. But then I read one book called Freakonomics. Then I started reading other economics books. And I realized that economics has nothing to do with money, but it has everything to do with people, because economics is a social discipline, and it studies how social animals like us, humans, interact with each other to get a system from one point to the other point. So basically, we're just studying human interaction. So when we're talking about economics, we're talking about how we humans interact with the system. So the systems that we're trying to create are systems of software, but I also would like to remember you that developing software is a social system too. So we're talking about economics. We have to take care of the economics of developing software and the economics of using software. Because software is changing the way that we produce software too, and it's changing the way that people use software to create other kinds of value. That's why software is so important, and that's why economics is so important today. We need to study very well how people interact to deliver better software. And it has everything to this discussion about DevOps, as I said before, as the feedback loop, because we need to have a better, faster, and more feedback loop in each one of our release cycles. We need to shorten this time so we can quickly validate our development hypothesis to check if we're doing the right thing and if they're doing the thing right. So we have this both sides of the same coin. We need to check if we're doing the right thing. What am I doing is going to be valuable to the end user. It's going to help somebody, some user. If I'm doing the thing right, is my code leading to bugs into production? So that's some of the questions that we can answer with the feedback loop. And for that, we need to reduce the batch size, as I said before also. We need to reduce the amount of things that we put into production in each one of those releases. Ideally, we would have just one commit per release. So I don't know how many of you will be able to get to this point to generate just one commit, one release into production. But maybe we don't need to be Netflix, Amazon, Google that are able to do multiple deploys per day. Some of these companies generate releases each 13 seconds. But I don't know how many of us has so many teams that will be able to do such amount of releases per day. So for many enterprise companies, if you're just releasing once a month, if you do that twice a month, you already improve a lot. If you are able to release once a week, you're already doing good. If you're able to release once a day, then maybe for your economic point of view, it's the perfect release cycle because you will not be able to code your functionality in a faster release cycle. And so when we're talking about releasing code into production, many people are worried about, I'm never going to be able to deploy every 13 seconds or 15 seconds into production. And I always like to say that to be able to deploy more frequently, we need to be competent people. And when I'm saying competent, I always believed in my life that we are here for some purpose. We are here to be better in something. And One of the greatest things that I've learned in my life was last year. I went to a local university in Brazil. I talked to a professor, and I always talked about, oh, we always need to improve ourselves. We need to be competent. And then he told me the origin of the word competence. In fact, to be competent people, we need to have competence. And in my entire life, I believe that competence was the same thing as proficiency, because to be competent in something, you need to be proficient in something, which is the ability to do something very well. As always, try to achieve this kind of competence. But then I learned that competence comes from Latin, competere. And competere, usually when we talk about competence, we remember about compete or competition. So we're trying to compete with other people. But originally in Latin, competere doesn't mean to compete with other people, but competere means to compete against yourself. So to be a competent person is to compete against yourself every day. And if by the end of the day, you're a better person compared to when you wake up, you are a competent person. So competence has everything to do about self-improvement and nothing to do about proficiency. So to be competent in releasing software into production, we don't have to be able to just release like every 13 seconds, but instead, if you are able to improve every day or every week or every month to reduce the release cycle from 1 month to 3 weeks, from 3 weeks to 2 weeks, and so on, then we are competent people until we can achieve the ideal release time frame for our own companies. So that's one of the things that I would like to leave to you to think about. We need to be competent, but competent means self-improvement, and we need to improve every day. I think the saddest day of my life would be the day that I did something and I had to say, I'm never going to be able to do something that great again. This day I think I'm going to retire, because it would be a very sad day. I wouldn't be improving anymore. So we always need to be improving. So when we're talking about competence, means we need to reduce our release cycle until maybe we can reach a non-commit, but each one of you knows which is the best batch size for you to be deployed into production. So I also defined it before. Batch size is the amount of things that release into production, that we put into production into each release. And the smaller the batch size, the lesser the risks that you have to put in code into production. So at least from an economic point of view, for your managers, it's very important for you to reduce the batch size, because it leads to less risk in deploying. I also talk about the maintenance window. You can reduce the batch size until the moment that your batch size is equal to your maintenance window. And you can't deploy faster than that, because you need a specific time of the day to do your deploy, or a specific time of the week to do the deploy. So if you want to deploy faster than that, we need to achieve some things like zero downtime. And I'll explain again the first deployment pattern for you. I'll try to explain some deployments pattern like blue-green deployments, Canary deployments, rolling upgrades, some A/B testing, use some dumb strategies and some smart strategies. So I'll show you again a blue-green deployment. So blue-green deployment is the easiest of all, the simplest one to implement. It basically means that you're going to have two separate production environments running in parallel. So you're able to just update one while the other one is servicing requests. Then you can switch it back, and the user doesn't perceive the downtime. So again, you have multiple clients issuing requests. You need to change your architecture. You put a proxy in front of that. Then after you put a proxy in front of that, you're going to duplicate your environment. You have two separate environments. You're going to put your state-of-the-art application in a separate data store, usually an in-memory data source for your session replication. And as I said in the previous session, to achieve zero downtime with blue-green deployments in your database, you need a lot of different techniques. But then you're able to just update the green deployment, and then when it turns back, what does an application turn back into production means? Because usually, if we're developing Java applications, one thing is for your application services to be responding to 100 OK in your application using the index.html. It is servicing requests, but maybe it has not warmed it up already, so it's still slow. So maybe you need to wait some time for it to be warmed up to get your full amount of requests into production to that server. So you need some way to check if your server is online, and if it is online, if it's warmed up enough to handle all of the production requests. So that's two different kinds of check that we need into production. And we can do it manually or we can do it automatically. I'm going to show you how some cool technologies like Kubernetes and OpenShift can handle this kind of issues for us. So after you update the green and it's already warmed up, you can then switch, you can update the blue deployment, and when the blue deployment comes to production, when it's okay, you can have both deployments servicing your production requests. So that's blue-green deployments are the simplest ones to achieve. And usually, like, as I said, before joining Red Hat, I used to be a software consultant. And in many scenarios, the simplest possible way to implement that was to just put a software like HA proxy, servicing as proxy for these two backends. So I'm going to open here for you an HA proxy configuration file. So you see, you can have this configuration file. It's very simple. You just say that you have a front end. For that, you're binding on port 80. You're servicing HTTP requests, and you have just one backend. In this case, I'll call blue-green. I'll say here that the backend blue-green is in the mode HTTP. I'm going to round robin the request, so each one of the requests is going to be intercalated to each one of the servers. I'm going to add some headers in my HTTP request, so I know that I'm forwarding for some of these backend servers. It's important for me to have this to know from which request this response came from which server this response came from. So I know, oh, it happened on deployment blue, or it happened deployment green. Because, you know, at the beginning, usually you have just two separate servers. But when you start to realize that you can have multiple deployment servers into production, you're gonna need a tool for log aggregation, for example. You just can't just keep SSHing into each one of the servers to know, oh, I need a stack trace. In which one of them it happened? Then you need to aggregate all of that. But for the first step, you just create an HA proxy. I have an option to HTTP check to check if the backend is online, so I know that it's okay. HA proxy also has a cool status interface, so I know if it's working or not. Then I have two backends server. I can have blue one, or in my case, I have a blue deployment. And then I can have a green deployment. Oops. Can I have a green deployment? Then I have the URL in the backend, so it's going to forward the request to these two backends. So I have other ways of checking how many requests must fail and everything else. But HA proxy by itself, it doesn't have a way to check if my server is warmed up already to service all of my production requests. So that's the simplest possible file for HA proxy for you to create a blue-green deployment. Then for you, if I want to change, my deployment, I want to simply remove the green backend from production. I just have to get here and comment this line, and just restart HA proxy, or better than that, I just handle the process that it needs to reload the configuration. HA proxy is a very fast reload service, and when you reload the configuration, it doesn't drop the requests. So you can just comment the line, ask HA proxy to reload the file. It will keep servicing the request until they end to the old backend. Then when everything's okay, you can go back here, uncomment this one, and comment this one. Then you follow the process to update your software, and then you can do that again, and uncomment, and everything now is right into production. Of course, you're not going to do that manually. You're going to create scripts in your deployment process just to comment here, reload the configuration, update the blue deployment, edit again and again and again. And if you want to check more about HA proxy, there's a great script file, HA proxy CTL, which is a command line tool for asking HA proxy to get a server and remove from the cluster, add from the cluster, and back again. So that's one of the manual things that you can do. And usually that's the very first step for people that are trying to do blue-green deployments, because, you know, maybe you're not using containers yet. Maybe you're not ready to be using a container orchestration platform, but I think you should. So maybe you have this old legacy manually install a server and you're just replicating that to another server. So this is a very simple way for you to begin with blue-green deployments. And since HA proxy doesn't have a warm it up option by default, you have to implement by yourself. But usually, I have to tell you, usually the simplest possible option is that you get your bash script, your deployment script, you just update your server, and you can wait like 1 minute, 2 minutes, and wait it for warm it up. Then you just switch back to the green deployment, and so on. So that's a very easy and simple way that can work in many different cases. You can do all of this manually. That's how we did blue-green deployments before we had these modern container orchestration platforms like Kubernetes and OpenShift, and that's the things that I want to show you. Okay. So blue-green deployments, I can do it manually. I'm going to show you how to do it automatically later. Then another kind of deployment that we can do is Canary deployments. Canary deployments, they use the analogy from the coal miners. The coal miners, usually they have a lot of canaries in their jails, and they just walk by the mine using the canaries because the canary is very sensible to toxic gases. So another benefit is the canary sings. So you're walking with the canary, and the canary is singing. If suddenly the canary stops to sing, then that's a signal you should run away because something bad is happening. So this is the way that coal miners use canaries. And then we thought that maybe to put software in production, we could be using the analogy for canary deployments too. And basically, canary deployments into production means that we're still going to have a proxy servicing our request, and we're going to have one blue deployment. Then we just updated the green deployment, but I've colored that it's not green yet because it's yellow because it's just a canary deployment. And we don't want to put that new deployment into production already because something might go wrong and the canary might die. So we just configured the proxy. I want just 10% of my request to go to the canary to see if everything is going okay. Then you can monitor that. Then you can see the logs. If everything is going okay, maybe I can increase the amount of requests. Can be like 20%, 30%, depends on your use case. Then I increased the canary to 30%, and then the canary died. Okay, so something went wrong. He couldn't handle the amount of requests that 30% was too much for him. Then the canary died, then automatically I can figure out that, maybe the deployment isn't working right. Maybe I can stop the deployment in the green. I'll leave the blue deployment into production until I can figure out what is happening. So that's one way of doing canary deployments. Again, we can do it automatically. We don't need to do that manually. And also in terms of canary, we have dumb canaries and we have smart canaries. I'm going to show you some alternatives too. So, and another interesting deployment strategy is what we call rolling upgrades. Rolling upgrades is the kind of deployment strategy, and usually it is combined with canary deployments too. Dumb canaries, I'm going to explain the difference later. And with rolling upgrades, it means that usually you have more than one deployment environment into the production. Here I have 3 in my example. So you need it for scalability purpose or for reliability purpose. You have 3 nodes in a cluster, and you want each one of your servers running a different node. So you have 3 different ones. Then you can instruct your infrastructure software to update just one and check if everything is going well. Then you can ask to update another one, and then another one, and everything goes wrong. It just updates one by one each one of your nodes to check that everything is going right. And each one of these updates can be a canary deployment too, because they are not exclusive options. You can do a rolling upgrade, and each one of these rolling upgrades, you can do a canary deployment to check, to keep increasing the requests, to check if everything is going on. Okay, so because the simplest possible fail here is I'm going to try to start an application and the server doesn't go up. That's very simple to solve. That's a failed deployment, you know easily. But the problem and the real benefit of canary deployments is when you can successfully deploy the application, but it's not, sometimes it generates some errors, or even worse, the performance of the new deployment does not match the production requirements. So that's the worst possible scenario, and that's some things that with rolling up upgrades you can achieve too. But instead of just talking about, let's do some demos using that. I created here, let me mirror my screen. So instead of just talking, I have prepared for you some cool deployments. So basically here, I'm running I'm running on my notebook, I'm running a Kubernetes cluster, and on top of that, I'm running the OpenShift environment. Kubernetes is an OpenShift, they are both open source projects. Kubernetes is a project developed jointly by Google and Red Hat, and Kubernetes particularly is one of the most popular container orchestration platforms in the market, and it's based on the same technology that Google uses to deploy approximately 2 billion containers per week. So the guys at Google and we at Red Hat, we believe that if Google is capable of running 2 billion containers per week into production, then Kubernetes is also suitable for you to be running your 50 containers per week or 100 containers per month. So it should be more than enough for you to handle that. But if you get to know Kubernetes, Kubernetes is a very low-level container orchestration platform. And for you as a developer to create some more interesting developer scenarios or to have some more tools for you to automate like deployment pipelines or other tools that I'm going to show you here, like log aggregation and a nice, beautiful console for you to be managing your infrastructure. Then you need another software layer for that. So Kubernetes is very flexible. In fact, the Google guys and the Red Hat guys too, they decided Kubernetes will remain to be a low-level container orchestration platform because it's not the role of Kubernetes to be developing these developer-friendly tools and interface for you to use. Then it's the open source market should be doing the other part. So we have different implementations of platform as a service software that runs on top of Kubernetes. You have, for instance, Deis, which is one open source platform as a service that runs on top of Kubernetes. And from Red Hat, we have OpenShift, which is I'm going to show you today. Also, OpenShift is a software. It runs as a container inside Kubernetes, so you can access your Kubernetes. You can have your Kubernetes Kubernetes cluster, and you can run your OpenShift pods on top of Kubernetes, and you can access this beautiful interface. So what happened here? I just pre-deployed for you 3 different applications. I have a blue, a green, and a purple one. It's not just blue-green anymore. It's blue-green-purple because I'm going to use that for Zuul later. So I have 3 different deployments, but assuming that I have blue-green deployments, so if I get the blue URL, I get this beautiful blue background. If I access the hello or the green and the purple, for now that's what is working. So if I use a traditional software like HAProxy, I would have to do it manually. But since I'm using Kubernetes for the container orchestration platform, Kubernetes automatically creates a load balancer for me for each one of the services that I expose to my company or to the internet. So it just creates a DNS name, and behind that DNS name, I can have a cluster of many different copies of the same application, or I can or different versions of my application. So it depends on how I'm working. But here I'll get, for instance, this blue demo endpoint, which currently is blue. Then I want to change it to a green deployment. I want to switch the deployments because they are both running in parallel. I have 3 different environments running in parallel. And if I want to change that into production, it's very easy to do. I'll just increase my font. I have some pretty easy ways to do that. I can, and for that, plain Kubernetes can't handle that for you. If you want to dynamically change this, you need to OpenShift for that, because OpenShift uses a concept called root, which is not available in Kubernetes. So edit root, so edit this root called blue, and then I just open VI here. I'm gonna edit that. So here you can check that the specification of my root is telling me that I want to. The target port is 88 TCP. The service that I'm handling, the name of the service is blue. But then I just have to change this name here in the OpenShift configuration. As I save the file, automatically Kubernetes and OpenShift detected the configuration has changed. So if I open here the console, it's already going to show me that the blue deployment changed the route to another one here. Okay, I have 2 routes for the same guy. So if I just access now my blue deployment and refresh it, it's got a green. So I didn't have to do any configuration, everything else. And one of other benefit of using Kubernetes, for instance, it's Kubernetes automatically has health check. So it's just if that's an HTTP port, it checks if the port is returning 200. Okay. In fact, anything from 200 to 3 something means that for Kubernetes the pod is the application is okay. And Kubernetes also has the liveness probe. So it's not enough for Kubernetes to be responding 200 okay. It needs a timeout. It needs to respond 200 okay in HTTP in 2 seconds. If it takes longer than 2 seconds, then it's live, but it's not ready. So Kubernetes won't be issuing requests to this pod. Okay, so I just had to edit this file. I can do that back again. I can turn that back to blue, or I can change that to purple. I just saved the file, and it's automatically changed. So I have to do here purple already. But you know, I won't be editing my configuration in production like this way using VI, but it's not ops friendly. So maybe we need to an automated way to do that, usually with scripts. So you can put these scripts in your continuous integration server. You can use Jenkins to be automating and issuing the commands to Kubernetes and OpenShift. So I have a pretty beautiful here, like command line. You can use patch. So everything that I did using VI to add the route, I can use also the patch command. So it's going to change. I want you to change the spec to name. I want to change that to green. So if I use that in the command line, it's the same as editing manually. So I just patched that, and now it should be green if I access that. Now it's green. So it can be all automatically managed by Kubernetes and OpenShift, and you don't have to be just creating this whole infrastructure to be able to do very easy blue-green deployments. And if you're using particularly Kubernetes and OpenShift, you have also dump Canary deployments for free, because you know, since Kubernetes has the readiness probe and the liveness probe, each one of the deployments that you try to make into the platform, if it doesn't pass the test of the liveness and readiness probe, Kubernetes simply won't update your application. It will tell you it failed to update your application, so you get Canary deployments for free. Canary dump deployments, because that's the only thing. When I say saying dump deployments, because you can use smart canaries, smart deployments, to check with business logic if your canary is working fine, because you can trigger some kind of business value to your monitoring to check my canary is working fine into production, but I'm not selling anything because the pay button just disappeared from production. So my application is working fine, okay, but I'm not selling, so something is wrong. But that's a business metric. So dump canaries, as I say, which are managed by infrastructure, can only check if the application is live and if the application is responding in a certain amount of time. So for that kind of dump, and when I say dump, I do not mean a bad canary deployment, but that's the best thing that you can do only in infrastructure. And for the dump part, Kubernetes can do that for you. And automatically, each one of the deployments in Kubernetes is a canary deployment, because if the deployment fails, the readiness and liveness probes, it won't be updated. So it always creates a new deployment of your application. It tests the new deployment, and after that test, then it routes to your request to your new deployment. Okay? And Kubernetes also gets you for free the rolling upgrade strategy. So I'm going to show here my blue deployment. I'm just going to switch back to blue, or else you won't be able to see that. So here is servicing the green deployments. I'm going to switch it back that blue. And if I change here something that is wrong, Kubernetes will refuse to save the file for me. Okay, it just roll back and open the file again for me because, oh, your configuration is wrong. I can't accept a wrong configuration to to modify the properties into production. So, but here everything is right. Okay, and then it's again it's responding blue. So now I just changed my application here. So instead of blue, I'm gonna update that to cyan, which is a very light blue. So I'm gonna update my application. So I'll ask that to do. So this build part is part of OpenShift because Kubernetes, it doesn't build your images. You have to build by yourself and then just ask Kubernetes to upload that. But internally, OpenShift is just building your application, just uploading your application to an internal Docker, private Docker registry. And then it's going to use the Kubernetes rolling upgrade feature. Oh, it just pushed it. It's very fast. And you can see Kubernetes automatically is instantiating my pods. Now it has 1, 2. It's increasing 3 pods, 4 pods, and it's decreasing this one. And then it's going to fade this one. Okay, so Kubernetes automatically, because I said I want 4 copies, 4 instances of this application into production. So Kubernetes automatically realized, oh, I have more than one instance into production. So what Kubernetes did is he created. I have 4 pods. I created 1 pod. Check this pod. Is okay. It's running. Then I killed one. Then I create another one. It's running. Is it okay? Then I can kill another one. Then I create another one, 3. Then I create the last one. So in any time of moment, you ask, I need 4 copies into production. So Kubernetes, when it was doing the role upgrade strategy, it's assured that you always had at least 4 pods servicing your requests into production. So you get that for free because that's one of the default deployment strategies for Kubernetes. And as you can guess, it's very hard to be doing rolling upgrades using a manual deployment strategy. So you would have a hard time using HA proxy to be doing this kind of a strategy. So rolling upgrades are very, very amazing. And again, in Kubernetes, each one of the rolling upgrades is also a dumb Canary upgrade. And you get all of that for free just for using Kubernetes, right? And one of the other great things, when people think about containers, can I run my containers into production? Maybe, but containers are hard. I have to change my application to be running inside a container. One of the great things about Kubernetes, for instance, usually by default, Docker container is not. Some people say that Docker containers are stateless. It's not entirely true because containers can have a state. But the point about Docker containers is that the containers are ephemeral. So if your container just dies, you lost all of the state that you had inside your container. So you need some way to persist the state of your container outside of the container to be able to survive this kind of crash. And Kubernetes, by default, you can run your stateful containers too. If your containers need, if your application needs to save something on disk or everything else, Kubernetes gives you that you for free too. In fact, Kubernetes, the earlier versions of Kubernetes, it wasn't possible to run these stateful applications inside Kubernetes. But since the engineers for Red Hat realized that it was a requirement for many applications, then Red Hat contributed the code to Kubernetes. Now if you get Kubernetes, just Kubernetes, you get all of these stateful containers for free because we donated the code to Google to run inside of Kubernetes. And it's always a trade back. Many things inside Kubernetes are first implemented inside of OpenShift, and then later we contribute the code to Kubernetes so that everybody can benefit from this new improvements. So that's what you get for free using a nice platform like Kubernetes and OpenShift. But then maybe you need some other kinds of deployments. You need to be smarter. And when I say smarter, it also means harder in terms of requirements, because I believe 95% of the enterprise companies are going to be more than satisfied just by using Kubernetes and OpenShift. But if you have a more advanced scenario, if you're mature enough for that, maybe I need a smart deployment, because I want to check the Canary not based on the liveness and readiness probe. I want to check revenue, if it's selling or not selling. Then I need to time my Canary deployment not just to infrastructure, but also as business code. And if it is regarding to business code, then I need to change my application's code to be using this kind of information. That's what I say, smart canaries and smart deployments. And another very interesting deployment is also A/B testing, which I'm going to show you here. So I did some demo. So I can use smart canaries using not just infrastructure tools, but also business code tools. And for A/B testing is, if you're mature enough and you're able to be thinking about A/B testing is the ability for you. I have two different hypotheses about in the perspective of business value. So I have my current page, and I want to maybe if I change the color of my button, I'm gonna sell more. So you see, it has nothing to do with feature, but how we implement this feature. So we want to test an hypothesis. So instead of trying to think, blue is going to sell more, red is going to sell more, why don't we try that into production? But we don't want to disrupt our users, because if suddenly people stop buying, it's going to generate a loss of revenue. So we need to test this hypothesis in a small set of users, not everybody. So you could check, I want everybody that lives in a radius of 10 kilometers from some city. They're going to be my canary. They're going to be my A/B scenario testing. So I have the majority of my users running that alternative. Then I slowly kept testing if my new deployment is generating revenue or not. So I changed the color to blue. It was green, and now the color of the button is blue, and I test that, A/B testing. Some people use standard 50-50 and just check the metrics. Oh no, the blue is selling less. So blue is not a good option for a color button. So I changed that to other column. Then you just keep monitoring. But A/B testing means that you will always have two different versions running into production. So you need to route your request between one and the other, and maybe it's safer for you to start your A/B testing not with 50% of the users, but 5%, 10%, or maybe you want to test just the iOS users and not the Android users, or you want to test just the Firefox users. Okay, so you want to be able to be intelligent enough to detect which kind of user is accessing your application. Then you can route that users to your correct deployments. So A/B testing is basically the ability to have a smart router in front of your application, not just a dumb router that like we've seen before, and to test the hypothesis, not necessarily one is the new version, the other one is the old version. No, you can have two different feature branches for you in your source repository, and you want to check which one of these feature branches generates more business value. So that's the things that we want to try with Smart Router. So for that, before I show feature toggles, I want you to show some code. So here, one of the most popular smart routers implementations in the market is the Netflix Zuul router. So if you're talking about microservices and everything else, you know many of the problems that we're trying to solve today were already solved by some pioneers. Google, Amazon, and Netflix. And Netflix was kind enough for us to contribute their efforts back as open source projects, just as Red Hat did in a lot of different projects. Netflix decided to open source all of their libraries and stacks. So when you're talking about microservices in the Java world, everybody talks about Hystrix. You might have seen Hystrix in many different talks. Even Burr showed some circuit breakers using Hystrix. And specifically to solve the smart router problem, it wouldn't be that hard to implement that, but Netflix already implemented that for us. So Zuul, if anybody of you have seen Ghostbusters, Zuul is the guardian, okay, of the gates of the hell. Is that something like that? I've seen the movie, but it has been a long time. Uh, and I'm not that old too, but yeah, okay, but I remember, okay, the Ghostbuster memory. So Zuul is the gateway to your backends. And the interesting thing about Zuul, if you get the source code is ridiculously simple. There are very few lines of code inside Zuul, but what is great about Zuul is what it does. Basically, Zuul is an implementation of, if you ever implemented a servlet filter, okay, Zuul is basically a set of filters that you can dynamically reload them into production. So Zuul, in its default configuration, it uses Groovy scripts, which is a dynamic language. So it can reload their scripts dynamically. So you can just edit your root logic here in your code, and when you save this file, automatically it just starts responding according to the logic that you did. And if you want to know internals, Netflix uses Cassandra file system for a clustered environment. So every time you update that, you update all of the Netflix infrastructure with these files. I'm going to show here, all of my logic here is saying that a blue, blue, blue. So if I access my Zuul endpoint here, it should have returned something. Then let me check again. I'm going to stop here and run again. Because you know, demos. And it's running. Waiting a bit. Running. Let me check again. Oh, it's amazing. Local hosts. Okay, I can assure you that it was working just before I got on stage. So what can I do here? I disable the cache. Okay, since it's dynamically, maybe I can just move my code here. And I can comment this. So I don't want to change anything. I just want you to route to the blue demo. And it reloads each 5 seconds my route. So he should be running. One last try. Oh, that's the same URL. So let's check. OK, it's running. Well, I don't know what happened, but now it's servicing requests. Now if I do here, I want to change the route to, want to say that I'm going to do some round robin thing because that's not an iPhone. So it's blue, then I have a green and a purple. So I just save the file, wait for 5 seconds, then it's in production. And it's going to reload here. Purple. Then if I do that, keep reloading that enough, it will have to change between purple and blue. Okay, maybe I'm not doing that fast enough, but trust me, it's going to round robin because of my code. But maybe if I do that with an iPhone, if my user agent is an iPhone, then it's going to be responding blue. So I just have to change here my iPhone 6 Plus, then it's returning blue. You see, that's the kind of smart logic that I can add in my Zuul code, so we can, if the user agent contains iPhone, then I route to this deployment, or else I'm going to round robin to the green, to the purple deployment. So that's the kind of thing that you can do with Zuul. You can dynamically change the things. So you start monitoring if it's generating value, if it's selling or something. Then it's just, oh, I want 10% of my request to go there. I want 20%. No, I'm not selling. I'm selling less. Oops, roll back. Just remove the if that you created here on Zuul, and everything is right into production back again. So with Zuul, you're programmatically changing the way that your requests are being routed into production, and you can use your business logic inside here. Maybe you just want the premium users to be routed to these new deployments. Then you just need to find the user inside your code. Which user is that? Then you can route to appropriate deployment. So that's a very interesting thing to be doing with Zuul. But then maybe, okay, it's very hard for us to be using 2 different feature branches. In fact, I don't recommend, and many people, many different consultant companies don't recommend for you to be using feature branches too, because when you use a feature branch, you have 2 branches of source code, and usually people have a long delay before merging the feature branches back again. So usually it's a bad practice, and you need to have a very mature development process to be using feature branches. So now maybe you should still be using just the master branch or the trunk branch for you for those of you that still use SVN. So if you're using just the master branch, which is a good practice these days, you should not be using Zuul to keep track of your smart deployments. Maybe you should be using a feature toggle framework. Feature toggle framework, imagine that it's a magical if-else that you can put in your code. So you can just use some annotations inside your code and say, this code is going to be active if the feature toggle X is on, or else it's going to run this kind of code. So you're just dynamically creating the if-else parts of your code in your application using code. And a great framework for doing that is feature toggles. So feature toggles, particularly, I've been studying 2 different kinds of frameworks for feature toggles. FF4J, which in my opinion is probably the most mature by now. But you also have Toggle Z, is another feature toggle framework implementation. And at least FF4J has a very nice console, so you can just alter your code, and you can say that I want, and you can put this business logic inside FF4J too. I want that premium users, they run this part of the code, and the non-premium user, they run this other part of the code. So that's one of the things that you can do using feature toggles and FF4J. Of course, we might have some problems, because now when you're testing your application, you don't rely only on code to check if your application is right or wrong. You also need the feature toggle framework state to know if you're testing the right points of your code. So that's another challenge for you to be doing. But you know, architecture is all about trade-offs. You can use smart canaries and A/B testing using different deployments with a smart router like Zuul, or you can use just one single deployment and use a framework like FF4J or Toggle Z to be dynamically changing your application to production. And that's one of the very interesting things. Facebook did this kind of. Facebook decoupled deployment from software release. So you know the Facebook Messenger application. It was deployed like months and months before you were able to use that in production. So the Facebook Messenger application inside Facebook, it has been like there for, I don't know, 3 months before you were able to use it. The code was there. It was simulating requests and everything else. When Facebook wanted to launch that into production, it used a feature toggle framework internal from them and just said, I want Facebook Messenger feature on. Then you just open Facebook and the icon appeared. Oh, what is that? Let me try that. And OK, I can send some messages. I can try that. Oops, but my servers are not able to handle too many requests at this moment. So Facebook could just, turn off the feature toggle. Nobody else is seeing the Facebook Messenger inside the Facebook page. So it's one way for you to be quickly switching features into production. So that's another kind of way of releasing features into production. So FF4J and Toggle Z are the frameworks I'm currently studying. I clearly don't have a clear winner, at least for now. It depends much on your business scenario, what is your company culture. But so smart routing and feature toggles, I guess I would say that it should be used by like 5% of the enterprise companies in the world. Netflix, Amazon, Google, eBay, they're probably using this kind of alternatives for deployments. But for many of us, usually Canary, dump canaries and rolling upgrades will be more than enough for our business applications. So that's some of the things that I wanted to share with you. All of this material and much more is being produced and it will be available at our website, developers.redhat.com. I invite you to join our website because we have a lot of material. We also have O'Reilly ebooks written by Red Hat engineers. They are available for free if you join the site for free too, for download. The book that I'm writing about microservices and relational database will be available for free at least in the first month in the website too. My Twitter is @Yanaga. I would love your feedback, and that's what I wanted to say for now. Thank you very much. Okay. Thank you. If we have time for questions.
Hello.
Hello.
was wondering if you knew about Spinnaker from Netflix.
Yes.
And what's your take on that?
We internally we evaluated the Spinnaker to be integrated to be used as the deployment pipeline tool for OpenShift and Kubernetes. And in fact, Kubernetes and OpenShift they are open for integration. So if you want to use Kubernetes and OpenShift with Spinnaker, you're free to go. But particularly in OpenShift 3.3, which is available for use right now if you download from the website, we decided to use Jenkins 2.0 as the pipeline engine for implementation. You won't be seeing Jenkins, but we all use Jenkins file to define. And what I have to say, Jenkins has a much larger ecosystem. It's a much more mature project. So it was one of the things that made us decide in favor of Jenkins. But we have nothing against Spinnaker. We would, I think, more than happy to create some plugins to integrate with Kubernetes and OpenShift. It was just a matter of taste.
Okay, and I have a second question, if I may. You said there's like these smart canaries and dumb canaries.
Yeah.
But what about the canaries that are not dependent on business logic, but metrics? Like, for instance, HTTP calls and CPU or memory or whatever. There's also Netflix also have this automated canary analysis tool, which hopefully they will open source soon. I don't know when, but hopefully. Would you also build something like that by Red Hat?
We don't have something similar. At least we have monitoring tools, but you need to create your own custom metrics. Okay, but if regarding to at least CPU usage and HTTP error requests, it's handled all by Kubernetes. So the newest version of Kubernetes, which is also used by OpenShift, they have built in this CPU bounded triggers, so you can check if you can have canary checks using CPU, and you also have thresholds for HTTP requests. So that's one of the things that you can automate. But you know, if you want more complex or advanced scenarios for Canary monitoring, you have to embed this kind of logic inside of your code. Just like Netflix does embed all of that in Zuul. If you reach the Zuul page on GitHub, it's going to say that Netflix uses Zuul for load shedding, authentication, Canary, routing, etc., etc., etc. But the fact is, Zuul only does the filter part, and it issues the routing, the request to the different servers, because all of this smart monitoring, health checks, blah, 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 is done by other tools, and they don't publish the code that Zuul uses to do that. So you have to do it by yourself, so you don't have it ready to run, you have to implement anyway. Okay? And I think we ran out of time. Yeah, I'm available for questions later, and thank you very much again.